everyone. Thank you for joining our session. And welcome, everybody. My name is Diego Ortiz. I'm a Senior Data Strategy Solutions Architect at AWS. And today I have the pleasure to be speaking with Julieta from ANT.
I'm Julieta Anzola, Senior Cloud Engineer at ANT. So, Diego?
Yeah, so today we'll be talking about how ANT, a company that Julieta will describe better later on, how they built a hybrid data mesh by using Amazon SageMaker. So let's get started. Before we dive deep into how they built this solution, let me put a little bit of context here. Across the globe, we've seen customers that are trying to become data-driven organizations. While in that process, they also face several challenges. Business areas will always try to use the data in the way they believe it is best for their business. However, when you have several of them doing the same thing in their own way, you can end up with a fragmented data landscape and data silos. And this can hinder data sharing and data innovation. This can also pose security and compliance risks because there is no unified data governance strategy in place. Another challenge that we've seen in our customers is that in these complex data environments, there is no unified mechanism for discovery of data assets. So business areas end up looking for the central data governance team to provide them access so that they can discover and consume the data. So the combination of all these challenges in the end make the goal of becoming a data-driven organization a far-fetched one. So here is where our customers have turned to see the data mesh concept as a solution for all these challenges. But first of all, what is a data mesh? Well, this is a data architecture pattern where data domains are treated as one specific area of the business. So these business areas now are treated as independent domains, and they can consume and be interconnected with the rest of the organization through a mesh. A data mesh comes with also some benefits. For example, those business areas can also leverage their existing investments and integrate them into the mesh. Another one is that it improves data governance by pushing all those policies down to the specific needs of those business areas. It comes also with a business data catalog, which is a centralized mechanism for data discovery and data sharing. And this, in turn, enhances a self-service data sharing among all those business areas. In the end, a data mesh allows those business areas to be empowered to use the data and also start innovating with it. So now let's see how ANT built their own version of the data mesh on AWS.
Okay. At ANT Grupo Vázquez, we operate a multi-industry holding in Paraguay with over 20 companies across 5 verticals, generating more than 300 terabytes of data across different systems. Our challenge was clear from the beginning: how do we enable data autonomous data products development while maintaining enterprise-grade governance? Each company moves at different speed with different compliance framework, with different innovation cycles. Some need sub-second streaming analytics, and others demand ACID compliant batch processing with full audit trails. So traditional hub and spoke architecture wouldn't scale for us, but also implementing full mesh topology would explode our TCO. So we needed something different, a hybrid approach. So let's examine the architectural trade-off. In a centralized pattern like this, all producer and consumer teams route through a central data platform team. This data platform team managing all the infrastructure, and will this create a secure environment for data governance, create also a single point of failure in the middle of the pattern. Our sprint velocity was many times blocked in the data platform team dependencies. In the other hand, if we think in decentralized, this pattern, this with the shared data sharing across different domains, we face immediate challenge like data duplication ratios, inconsistent schema evolution, and of course, overhead in infrastructure. So our solution was adapting Dreamcore, our self-service ingestion data platform, building entire on AWS, started as a centralized platform, but evolved into a federated architecture. We also maintain our production layer centralized using EMR on EKS. We migrate from self-managed cluster to EMR on EKS. And we are adopting SageMaker Unified Studio for our decentralized consumption layer for democratized ML analytics capabilities. This approach allows us to transform our operational model without affecting our all 20 companies across the company. So this is our taxonomy. We create this diagram encoded in our IAM policies and network topology. We have three main domains. The central data domain is our nervous system, and we have also digital ecosystem domain and financial ecosystem domain. These domains are isolated through a dedicated AWS account, and they have their own S3 prefixes in our central data lake living in the central data domain. We use lake formation for sharing data across different accounts. That means, for example, if someone from payment teams need data from the central domain, they simply subscribe to in the business domain catalog. This allows us to implement this autonomy without anarchy. So in the technical side, we move from EMR, traditional EMR cluster, to EMR on EKS for flexibility. Our before state, we run one massive persistent EMR cluster, provisioning for peak job submission, which happened probably 4 hours a day. So we had a 35% average utilization, that meaning we were paying for 100 of the infrastructure to use barely a third part of it. Talking about job isolation was process level only, meaning one runaway Spark job could bring down others. So yeah, also our painful point was scaling time. In the traditional cluster, scaling time took around 15 to 20 minutes to new node to join the cluster. Now, each business domain runs in isolated EKS namespaces. Job isolation is enforced at 2 levels now. EKS namespaces provide hard boundaries, and pod-level security provides secure worklogs. EMR map one-to-one with this business domain with these namespaces and isolated them. Also, we implemented spot instances for reduced cost. We use 70% spot instances and 30% on-demand instances for optimized compute. And also, we are migrating some instances to Graviton 3 for memory-intensive workloads. But our game changers was Carpenter provision node in under 60 seconds. So we achieved this elasticity that we needed. Talking about numbers, we went from 35% average utilization in our old cluster to 80% utilization in our current cluster. That meaning 45% cost reduction using shared infrastructure and optimized compute. Also, through Carpenter, we can handle traffic spike in near real time with pre-warm node pools for predictable workloads. So at the bottom line, well, we are processing the same data at half the cost. So it's a huge improvement for us. So This is our production layer. Before we continue with the consumption layer, I'd like Diego to give some context on SageMaker.
Thank you, Julieta. So Amazon SageMaker is the center for your data, analytics, and AI on AWS. It comes with 3 main layers. The first one on the top is the Unified Studio, which is basically an interface where you can access different types of data functionality from SQL analytics, data processing, machine learning, model development, and even Gen AI applications development. We also have 2 other layers here, the data and AI governance, which we will dive into later on, and the open lakehouse. So let's dive deep into this layer about data governance. There is one key component here, which is the SageMaker catalog. And this is a business catalog. It's a central repository for both technical and business metadata for different types of data products, ranging from traditional data sets to machine learning models, Gen AI applications, and so on. The service comes with a set of integrations to have full visibility about your data products. For example, you want to see the data quality of those data products, it comes integrated into the catalog. You can also use metadata forms and business glossaries to classify your data products. And you can also see the full data lineage of all those data products from end to end. There is a bunch of different functionalities that are being added to this catalog too. So now let's see how ANT built on top of this SageMaker catalog to achieve their data mesh platform.
Okay, as Diego said, we'll see how we actually implemented this. If we said EMR on EKS give us elasticity, we can say SageMaker Unified Studio gave us velocity. We kept Dreamcore as our backbone, the place where data pipelines, ingestion, and transformation happens. But we needed something for our business user and data teams, an unified way to access and exploit that data that they produce. So that is where SageMaker Unified Studio became the missing piece in our hybrid mesh. I said SageMaker Unified Studio gave us velocity. Our user from a single entry point now can use their services for exploit analytics tools, and they can run simple Athena queries. They can spin up SageMaker notebooks, and even build Bedrock-powered apps using foundation models and knowledge bases, and publish in the SageMaker Lakehouse catalog, which each project from different domain, SageMaker Lakehouse catalog, organize the different assets under the right governance. And also, we implemented late formation tags. We replaced our old ticket-based approval for late formation tags. We create this taxonomy in our central data catalog, living in the central account, and share through different services like RAM in AWS. So our users can access all their ML, analytics, and Gen AI tools from a single entry portal. So I say SageMaker Unified Studio gave us velocity. This is the number, 75% faster onboarding for our new hires. Before, when probably you know the things, when someone joins the teams, we needed to open ticket for VPN access, package installation, security, and so on. But now, in just 5 minutes, they can spin up their environment through the blueprint in SageMaker Unified Studio. We create this template with CloudFormation, and they simply create environment, click create notebook, and start coding, no waiting for IT. Also, data access, probably our biggest bottleneck in the past, went from weeks to instant. Now, with our taxonomy and late formation tags, the access is instant when, for example, if you are in the payment teams and the data is tagged as a payment, you can query it, no waiting, and you start using it. So I will share some lessons learned in this journey. The first one, governance is not optional for sure, but must be declarative, not imperative. We kill our old ticket-based approval and replace with late formation tags. And as a result, we achieve this governance at a scale with autonomy without human bottlenecks. The second one, balance is dynamic. They are no perfect formula for centralization versus decentralization, and that is okay. We started fully centralized because we need to establish some standard, and then when the domains proven maturity, we release the control, and that works for us. And last one, probably one of the most important, culture matters as much as technology. You can build the most efficient and even fancy architecture, but if your people don't trust it, it fails. So our advice is keep it simple and build adoption first. So, all right, this is all. If anyone has some question, we are here. Please complete the survey. Thank you so much for listening.